You want to obtain cash by using an ATM, but it's dark and you can't see your card when you insert it. The card must be inserted with the front side up and the printing configured so that the beginning of your name enters first. Complete parts A through C. Now for part A, it says, what is the probability of selecting a random position and inserting the card with the result that the card is inserted incorrectly? Select the correct choice below and, if necessary, fill in the answer box to complete your choice. Now, the card can be inserted with the front side up or back side up. Here we have two ways. Also, the card can be inserted such that the beginning of your name enters first or the ending of your name enters first. So there are an additional two ways of entering it here too. So the total number of ways inserting the card is going to be 2 times 2, which is equal to 4. Now out of these 4 ways, there will only be one correct way of inserting the card. So the probability of selecting a random position and inserting the card with the result that the card is inserted correctly is the following. The probability of inserting the card correctly is equal to 1 over 4. Now for part B, it says, what is the probability of randomly selecting the card's position and finding that it is incorrectly inserted on the first attempt, but it is correctly inserted on the second attempt? Assume that the same position used for the first attempt could also be used for the second attempt. So, we know the following from the part A, that the probability of inserting the card correctly is equal to 1 over 4. So the probability is 1 over 4. Now, we want to find the complement of inserting the card correctly, which is to find the probability the card is incorrectly inserted. So the probability of inserting the card incorrectly is taking 1 and then subtracting 1 over 4, which is the complement of inserting the card correctly. So 1 is the same thing as 4 over 4. 4 over 4 minus 1/4 is equal to 3/4. Therefore, the probability is 3/4. Now, the probability of randomly selecting a card's position and finding that it is incorrectly inserted on the first attempt, but is correctly inserted on the second attempt is the following. We're going to take the probability of inserting the card correctly times the probability of inserting the card incorrectly, which is equal to 1 over 4 times 3 over 4. 1 times 3 is 3. 4 times 4 is 16. So therefore, the probability is 3 out of 16. Now in part C, it says, how many random selections are required to be absolutely sure that the card works because it is inserted correctly? Well, this is a trick question, so there is no finite number of attempts because it is possible to get the wrong position every time.